Hello and welcome back to Box of Shorts, where we take difficult ideas from GCSE Science and we try and make them a bit more straightforward for you and give you some lovely practice to do on them. So what we've been looking at till now is Earth's atmosphere and how it's changed over time. And today we are going to be looking at carbon dioxide and how that's changed over time. So just by way of starter, we'll revisit a diagram that we've seen before. That looks a bit like this. Okay, so first off, actually, I'm just going to kind of move this out of the way because it's annoying me. Okay, goodbye. Right, so first off, this is water. Where did this water... I said that I was going to get rid of it because it's annoying me and it's come straight back. Right, so where did all of this water here come from? So this water that's down here, where did this all come from? Say your answer in 3. 1, 2, 3. I'm hoping you said it's condensed water vapor from the air, or better, you said it's from volcanoes right back at the beginning of the Earth's atmosphere. Now, last lesson, we looked at these little green dot things, these unicellular organisms. Okay, what were their names? What was the name of that unicellular organism? Say your answer on 3. 1, 2, 3. I'm hoping you said algae. And the algae are green. Why are they green? Say your answer on 3. 1, 2, 3. That's because they've got chloroplasts. And because they've got chloroplasts, they must do what? What do they do? Say your answer on 3. 1, 2, 3. Photosynthesis. Very good. And photosynthesis pulls one gas out of the air and puts one gas into the air. Which gas is pulled out of the air? Say your answer on 3. Which gas is pulled out of the air? 1, 2, 3. Carbon dioxide, the topic of today's learning. CO2, carbon dioxide. Which gas is put into the atmosphere? Say your answer on 3. 1, 2, 3. Maybe you said oxygen. But the reason why this is so important is because Earth's early atmosphere was mostly made up of one specific type of gas. Which gas mostly made up Earth's early atmosphere? Say your answer on 3. 1, 2, 3. Carbon dioxide. So we could write early atmosphere, and this is 4.6 or so billion years ago, would be mostly, over 90% carbon dioxide. Today, about 0.04% is carbon dioxide. The question that we're going to be addressing today is, where did all the carbon dioxide go? We've already given one answer. One answer is it's taken in by algae. And we said last lesson, it wasn't just the algae, it was also the trees that were taking in carbon dioxide and producing oxygen. So already we've got one way that carbon dioxide is removed from the atmosphere. So we've got, let's do it as a question. So don't write this down yet. How is CO2, or how was, that's better actually. Let's go for how was CO2 removed from the atmosphere? And one is taken in by algae and plants in photosynthesis. Now, let's make things a bit more complicated, because the tree might take in all of that carbon dioxide, but the tree can also release carbon dioxide, and the tree releases carbon dioxide when it dies. So if a tree, say, dies, right, falls down over here, it might die, and then bacteria might munch on it, and they'll release the carbon dioxide right back again. So, for many things like algae and trees and stuff like that, a lot of the carbon dioxide they take in goes straight back out to the atmosphere again when they die. So as long as they're alive, they're taking it in, and then they die, and it goes back up into the atmosphere. However, something else can happen when they die that will make things a little bit different. So let's go back to that tree. So this is the ground. This is the tree. And the tree's got all of this carbon in it. And that tree, in this case, gets covered in mud, like that. So bits of dirt, other leaves, maybe some rocks, cover it up like that. And over time, this layer builds up and builds up and builds up, like so. And I mean, I want you to imagine that you were that tree for a second. You've got all of this dirt and mud and stones weighing down on you. That's like quite heavy. So it's kind of pushing down on you like this. It's squeezing you, it's squeezing you, it's squeezing you. The scientific word we use for that is compress. And then again, over time, more dirt, more dust, more sand, more rubbish, until you can never know that the tree was ever there to start with. And all of this is pushing down and pushing down and pushing down. Now, over time, what happens is that tree ceases to be a tree. And by that process of being squeezed, when the conditions are just right, it turns into black, lumpy things that we call coal. And you will have probably already learnt about coal. It's a fossil fuel. And coal exists in big deposits underground. And before humans came along, we'll talk about what humans did in a later lesson, but before humans came along, it just sat there underground for such a long time. And it didn't do anything. And the carbon dioxide that was from the air, from the atmosphere, see here, this carbon dioxide that was from the atmosphere ends up in this coal underground. So that carbon dioxide goes from the air into the tree and then stored up underground as that coal. Now, of course, that's not the only fossil fuel that is formed. You've got coal. Sorry, I should do that in black. This is coal. Ah! There we go, that's better. We've got coal. You also might have big fissures and caves underground where you have crude oil. And if you've done the unit on crude oil already, then you'll know quite a bit about that already. And that's the thick black kind of liquid stuff. So I'm going to fill that in a bit. So that's this thick black sticky liquid that we use for petrol and all sorts of other things. And then you've also got areas underground which are filled with something called natural gas. And again, it depends on what organism dies, right? So plants, when they die, mostly form coal, and then algae, I think, when they die, they form crude oil. And then if the conditions are right, then you can form natural gas. But I'm not actually a particular expert in that area. Anyway, the point is that all of this carbon dioxide from the atmosphere ends up in this, locked up in this coal, crude oil, and natural gas. And that's the word actually that we use. We use a phrase called locked up. And that's because the carbon isn't going anywhere. It's locked up. Do you remember we said the carbon that was in a tree isn't really locked up because it can just go out again over here where the tree dies. So it's not locked up. But if that tree turns into coal, or it turns into crude oil, or it turns into natural gas, then it is indeed locked up because all of the carbon that was in the atmosphere is now stuck there underground and it's not going anywhere. So you end up with these massive areas where you've taken all of this carbon dioxide out of the atmosphere and stored it in this coal, the crude oil, or the natural gas. So that's kind of our second way. We'd say locked up in fossil fuels. And that would be coal, crude oil, and natural gas. What's the third way? The third way is also kind of complicated, but we're not going to go into huge detail. So again, you've got this water like this. Now, carbon dioxide can actually just dissolve straight into water. So if you've ever had like a fizzy drink, right? So like a can of Coke, you know, when you open it, it goes, tss, that's because it's got loads of carbon dioxide in the water. What they do at the bottling plant where they make the Coke is that they pump in loads of carbon dioxide into the water, and it can dissolve in, it dissolves in seawater as well. Not enough to make the seawater fizzy, right? But there is, you know, still a little bit in there. And whilst it's in the water here, it can form by reacting with other minerals. We'll just write minerals for the minute because I don't want to make it too complicated. In the water, it can turn into what we call sediments, which are like tiny bits of rock. And those tiny bits of rock, like this, fall to the bottom of the sea. And then over time, those form into bigger rocks, and then bigger rocks, and then bigger rocks, and so on. So these rocks, what should I call them? The carbon is now part of the rock. So the sediments fall and form rock. And the type of rock is called sedimentary rock. Now, this is a bit difficult to explain because, you know, some people have learned more about rocks and the rock cycle than others. So it's a bit difficult to know exactly where to pitch it and, you know, what exactly to know. But I think what will be sufficient, if, you know, some of that makes sense to you and others is like, oh, sir, I've got no idea what we're talking about. I think what will be sufficient is to know that the carbon dioxide reacts with things in the water and eventually forms rock. And we call that rock sedimentary rock. Now, of course, that is, again, locked up. Like rocks are, they're pretty boring. They don't do all that much. So all of that carbon gets stored. And again, that phrase that we use is locked up in sedimentary rock, which is formed from sediments, which in turn is formed from carbon dioxide dissolved in the oceans. And you don't really need to know much more than that. So again, the carbon dioxide, we'll go back and do it one more time. I'm not sure I did a particularly good job of explaining that. The carbon dioxide dissolves in the water. In the water, it reacts with various minerals. It turns into these tiny little bits of dust called sediments. They eventually form rock. And then that means that the carbon is locked up in that rock. And we call that rock sedimentary rock. Hopefully that is clear. All right, that leaves us with 3 major points over here. And it is, by the way, significantly more complicated than this. I've tried as hard as I can to break it down to the 3 simplest kind of principles. And, you know, this is more than enough to get you by, but it is a bit more complicated than this as well. And I actually I drew myself a massive flow chart that I thought didn't really help anybody. So I've not used that here. What you can do is write those 3 points down and get ready to answer some questions. So pause the video and write those 3 things down. Okay, you should only be listening to my voice if you've written all that down now. And it means you are ready to answer some questions, which are over here. Okay, so in your book, have a go at these questions. And again, as ever, I remind you to make sure that you actually do these questions and don't be lazy. Okay, so you should have done those questions now, and you certainly should not be listening to my voice until you have done them. Let's go through them together. What does the phrase locked up mean? There's a few different ways to put this. You could say stored, or you could say not easily released. I think that's probably the best way to put it, that it's not easily released. You know, we can get the carbon dioxide out of rock. It's just really difficult. So, you know, saying that it's not easily released would be enough. Two substances that contain locked up carbon. So that would be fossil fuels and sedimentary rock. Some of you may have given the specific fossil fuels as well. That would have been fine. So if you said coal or oil or natural gas, that would be okay. From memory, 3 routes through which carbon dioxide is removed from the atmosphere. I'm not going to write this down because we wrote it down before, but the 3 routes are taken in by plants or algae, locked up in fossil fuels, or locked up in sedimentary rock. How did the oceans form? Again, this question we've done a few times. So we said earth cooled, and the water vapor condensed. Nice and straightforward. Describe how the amount of carbon dioxide in the atmosphere has changed over time. Now, it's really important. We'll do more of these as time goes on. But this question says just describe how. You don't need to explain anything. You just need to say how has the amount of how has the amount of carbon dioxide in the atmosphere changed over time? So don't go talking about photosynthesis and stuff like that. You just say it has decreased. Oh, no, this should be in purple. You just say it has decreased. And then you're done, right? You've described how the amount of carbon dioxide in the atmosphere has changed over time. That's enough. This is a cracking question. Why was it necessary for the oceans to form before the amount of carbon dioxide in the atmosphere decreased? Now, I've put this as a 5-mark question. It could probably be longer. I'm hoping you all had a go at it. What tends to happen in GCSE science is that students just look at questions like this. They see it's 5 or 6 marks and they just don't bother doing it. But like, it really is easy. It's just about taking the stuff that you've learned and tying it together. The major piece of advice I'd give you always with these longer questions is to use bullet points. So why was it necessary for the oceans to form before the amount of carbon dioxide in the atmosphere decreased? So the important thing here is oceans allowed life to form, right? That's really important. Without the oceans, there's no life. So oceans allowed life to form, and algae and plants start photosynthesizing. There we go. That's 2 marks already off the bat. If you're one of those people who didn't write anything for this and you think actually now I could have a go at this and I could fill in the rest and write some more stuff down, then I suggest pause the video and do that now and only press play when you've had a good go at this. Okay, so you should only be listening to my voice if you've had a really good go at this question. We've said that oceans allowed life to form, algae and plants start photosynthesizing, and then you can say carbon dioxide gets locked up in fossil fuels. And again, like without the organisms, without the living things to form fossils, you're not to form fossil fuels, you're not going to be able to lock up any carbon dioxide in it. And then the final one is the one we were talking about before, where we said that carbon dioxide dissolves in the ocean. So the carbon dioxide dissolves in the ocean, reacts to form sediments, and then it gets locked up in sedimentary rock. And there we have, you know, a really decent 5-mark answer without particularly a huge amount of effort. You know, there's nothing here that I've not taught you in this lesson, which only took a few minutes. So that's 5 pretty easy marks. I would suggest you do bullet points. I would suggest, you know, you flesh out the bullet points a bit more. So instead of saying carbon dioxide gets locked up in fossil fuels, you say the carbon dioxide is then locked up in fossil fuels or something along those lines. But in principle, you know, if you wrote this in an exam, I would be surprised if you did not get all 5 marks. That is all we've got time for in this video. In the next video, we will look at other changes to the atmosphere, including how the amount of oxygen has changed over time, and you should have a pretty good idea about that already. And we will also look at how the amount of nitrogen has changed over time. Thank you for listening. I'll see you again soon.